So the top of this says right triangle trig, cool. It says inverse functions, which is not a word you've heard me say yet, so that is definitely the new part. Let's hit the pin. This top stuff is exactly like the one we just did, so we're gonna go rapid fire round. Who can tell me what the sign of A should be? It's a fraction. It would be 4 over 5. Nice job. And the sign of B? 3 over 5. Nice. Again, the first one we're standing up here. We're doing opposite hypotenuse. This is just warming ourselves up. The cosine from A would be 5 over 13. And the sine from A? 12 over 13. And the tangent from A? 12 over 5. Opposite over adjacent. Sweet. So one person in class knows how to do this. I'm a great teacher. Let's get some other people. Does anybody else? Oh, for this one, I see that we're missing one of our sides of our triangle. I see that we have 8, 15 blank. Do we need the Pythagorean theorem? So we are going to need the Pythagorean theorem to find that third side, unless we can remember a Pythagorean triple. If we can remember that Pythagorean triple, those were not, wait a second, this one, not 2. 3, 4, 5, 8, 15, 17, ding, 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 that's the one that we want. 17 goes here. That saves us a lot of work. You know, we don't have to do 64 plus 225 is equal to c squared, which is 289 is equal to c squared, which is the square root of 289, which is 17. But let's get at least one more of these. I know there's one with 5. Yep, 5, 12, 13. If you didn't tell, that's literally the top 3 questions here are the nice trig Pythagorean pairings or Pythagorean triples. So from here, the cosine of A would be 8 over 17, and then the cosine of B would be 15 over 17. Obviously, I'm writing pretty small here. The sine of A would be 15, 17. The sine of B would be sine from B, 8, 17. And then when it comes to tangent, or from A, 15 over A. And from B, 15. So just a little bit of making sure we know how to set this up, because if we don't know how to set this up, we're doomed today. Also a pretty nice little kind of recognizing how our triangle works. If you're working with the cosine of A, it's going to be 8 over 17. If you're looking for the sine of B, it is also 8 over 17. Because once you switch those angles, then your opposites and adjacents switch. So there's a little bit of some relationships that you can start to pick up on and start to learn. It almost makes it more confusing if I over-explain them. So as you work with these more and more, if you start to pick up some relationships, sine of this kind of looks like tangent of that, nice. Those are nice little shortcuts to always have. Now here's where we're going to be today. Here's the new stuff. We've got 15 and 15, and we do have an x, and we do have a missing side. But do we need to find the missing side? Not really. This question doesn't ask us to find that missing side. We'll call it the hypotenuse just to be fancy. This question asks us for the angle here. Okay, if we need to find that angle, it's the angle inside the triangle, and we have not the hypotenuse, we have the opposite and the adjacent, so tangent. How can we set up a little equation for that?
15, tangent 15? Oh, wait, no. Tangent X.
Okay, nice, I like that. So we're gonna set it up with tangent x is equal to opposite adjacent. 15 over 15. Okay, nice, and that makes sense because remember the tangent of the angle should be equal to a fraction. This is where I kind of warned you yesterday, the tangent doesn't deal with the fraction. The tangent outputs the fraction, okay? We need to give the sine function, the cosine function, or the tangent function an angle to deal with. Now, if we're looking at our calculator, I certainly know how to do 15 divided by 15. That's easy, I know how to do that in my head even. 15 divided by 15 is 1. The real problem is, I need to solve for x. We saw some questions last time we did this where it was, why don't we divide both sides by 5? Why don't we multiply both sides by x? And you had to do a little bit of solving. So what are we going to do for this question? Make what, the tangent x part a fraction? Okay, if we make this a fraction which is divided by 1, what are we going to do now? Multiply what?
You multiply by 15.
Okay.
You butterfly method?
Okay, butterfly, sure. So that puts 1 times 15 is just 15. Here. Don't do this, I'm just going to write down here for a second. Okay, so then we're going to put 15 tangent x equals 15. But we still need this x by itself, and we're not really making the x simpler. What are we going to do, divide by?
Divided by tangent.
Okay, so that is more so what I was looking for. I'm going to back up a little bit here. We, instead of doing this fraction stuff and multiplying both sides and all that, we just want to leave the x where it's at. Oh, not erase. Come on, Mr. Carter. Come on, get it together. We just want to leave the x where it's at. It's the tangent that we want to move. And here's where we're at as trig students. This is basically all we're going to learn today. I'm going to tell you in the next 10 seconds. Is tangent a number? No. Tangent's not a number. So can you divide by tangent? No. Tangent is not a number. I mean, what are we going to write? Like this? 15? Right? I mean, that, you can even try typing that in. It's just not going to work. Tangent is not a number. So we can't divide by tangent. Tangent is a function. Tangent is like a process. Just like squaring something is. Just like the square root of something is. And so we need to do, the title of your notes, the inverse tangent. So, everybody look at your calculator for me. Do we see sine, cosine, tangent? Near the middle. Those are buttons we're going to be pressing a lot. The blue button at the top, which is the second button, is going to give all of your keys basically a whole second option on them. And so when we press blue tangent, it's not going to stay with tangent, it's going to go to the second tangent, and that's going to give us the inverse tangent. It's going to look, I guess I'll write it here. It's going to look like tan with that minus 1 exponent and then parentheses. Now, we probably learned, or we definitely have learned inverses when it comes to algebra 2. We've definitely learned it before, but inverses is one of those things where you learn it and it's easy, and then you take the test, and then you forget it. Inverses are opposites. Simple as that. The inverse works opposite of the regular kind. So our regular tangent wants to take an angle and give back a fraction. But that inverse tangent does the opposite. That inverse tangent wants to eat a fraction to give you an angle. And that's what we want. We don't want to output a fraction, we want to output an angle. So, long story short, you cannot divide by tangent. You have to use the inverse tangent to move it to the other side. So once we try to move this, it's going to make our final setup look like the inverse tangent of 15 over 15. So on our calculator, we're going to go second tangent alpha y equals enter 15 on top of 15, enter. And if you're in degree mode, I hope you're in degree mode, what is the angle of x? 45. 45. X equals 45. All right. Long story short, if you are looking for an angle, you gotta press second tangent, not regular tangent. Now let's practice this. What if we messed up and we accidentally hit normal tangent? What does normal tangent of 15 divided by 15 look like? Tangent alpha y equals enter 15, bottom 15, enter. I got the decimal 0.017. Is that what you guys got?
Yes.
Does that make any sense that our angle would be less than 0.1? No, right? Doesn't make any sense. So even if you do it wrong, just think for a second. Probably not gonna make a whole lot of sense. Okay, I've done a lot of talking. We did one question. These are really fast questions. Step 1, set up a SOHCAHTOA. Step 2, if you're looking for an angle, use the inverse. So let's get a SOHCAHTOA. Who can help me out with a SOHCAHTOA of x?
Just close.
Cosine, nice job. Cosine of the angle, do we know the angle? Nope. Is equal to a fraction, 14 over 20. And real simple, you cannot divide by cosine, you gotta do the inverse cosine. So we're going second cosine alpha y equals n. The top is 14, the bottom is 20, and it looks pretty good. In fact, I'm getting a number very similar to the last question that we did. Did you guys get 45.57?
Yeah.
Sweet. I read the directions. I didn't see anything about decimals, so let's just go with 2 for today. And at that point, as fast as we can set up the triangle, second trig fraction done. Second trig fraction done. These are not long questions. So let's go for this one. Are we using sine, cosine, or tangent?
Sine.
Nice job. Sine of x, because we don't know what the angle is. Fraction, opposite over hypotenuse, 8 over 17. Make sure you press second, then the sign of 8 over 17. I heard 28. What's the full decimal version?
28.07.
28.07. How do you feel about this? Doing okay?
Yeah.
All right, 3 questions. Do these. I'm gonna come around, kind of see how you're doing. Again, as much talking as I did, this is not really all that complicated. We got lunch coming up in 15 minutes. It's coming soon. Should be doing a little bit of writing and then a little bit of typing.
Are we doing the back or the
Just the front. Just get those bottom 3 done. I'm gonna go over it in 1 minute. All right, here's what I got. Did you get the same trig setups that I got? Did you get cosine 7 over 25? Did you get sine 5 over 10? Did you get tangent 1 over 2? We're good with all 3 of those? Okay, if you got all 3 of those, all you gotta do is type them into the calculator. Here's what I'm gonna do. I'm gonna use the calculator to give me a random number between 1 and 20. And we're gonna start here, Dora, you're number 1. And in the back corner there, you're gonna be number 20. And we do have a missing person there for number 10. And so if it says number 10, it'll be me. A random number between 1 and 20. 19. Naya, that is you. Naya, did you get an answer for this first one?
Yeah, I got 73.75.
17.75, you said? Did we verify that? That feels pretty good? Nice job. Person number, it was actually 19 again. But we'll go to number 3. What do you got, number 3? X equals what? 30? Nice, X equals 30. So quiet, all the risen that you did earlier, it's funny. And number 11, that's 4, 8, 9. I was number 10, and 11 is Siani. Siani, did you get this answer here? For this last one? Nice. 26.56. You rock. We good on that?
Yep.
At the end of the day, is this hard? No. Have we ever seen this before?
Yes.
Okay, that's what I figured. Shouldn't be too bad. We're still kind of in review phase. Let's flip it over. Now, at the top here, it says determine the value of the missing angle in degrees, minutes, seconds. Here's what's up. I talked with the other trig teachers. We decided degrees, minutes, seconds really kind of sucks. I'll tell you right now, yeah, it's awful. Good news is we're not doing it. Sweet. Calculator fatality. Let's go ahead and get rid of those top ones. I'm not worried about degrees, minutes, seconds. We seem to do pretty good about that. Alright, we're not going to work on this question, but we are going to work on the one here in the middle. This is going to be at least a two-stepper. We have to really think about what's going on. First of all, I don't really like this picture that much, because when you take geometry, you learn that anytime you have these nice curves in the corners, that they should be matching. And so if that was true, what would x be equal to? 40. We could just be done that fast. But this question, whoever drew this didn't do a good job. So I'm going to put an extra little curve in that corner. And now, this corner's got 1, this corner's got 2. They're going to be different. Okay? And we could also kind of tell they were going to be different because we had a 6 over here and a 5 over here. It's just a bad drawing. I don't know which teacher made this up, but no big deal. Now, our goal is to try to figure out this x value. We got to try to work our way over there. In order to make kind of one of these things work, you kind of got to work with 3 pieces, right? You need the sine or the cosine of the tangent of one piece is equal to a fraction. You kind of need those 3 pieces to set up. Now, you need 2 of those 3 so we could find 1, right? If we got an x right here, then we got something like 9 and 12, that works, you know, or maybe we can switch this stuff around. What is going on? Try to do something fancy. Try to do something fancy and got punished instantly as always. No big deal. Alright. Undo all this stuff. Whatever. You gotta have 2 out of 3. If we look ahead, oh my god. Come on. If we look ahead to the triangle that we're trying to work with, the issue is we only know one piece of this triangle. We only know the 5. We don't know the angle, we don't know the side, and we don't know the hypotenuse. So we've only got 1 out of 3 and we are stuck. However, of course, this triangle has 2 that are connected, and this other triangle is actually in a lot better shape. We have the angle and the side. We've got 2 things, which means we can find out more, because you have to have 2. Now, what is our path to the answer going to be? What do we want to do? What do we want to use these 2 things here to find? Nice. The hypotenuse. We want to think about this line, and why is that line so nice and important? Because it is shared by both triangles. So if we figure out this line, it's going to be the correct distance for our triangle A, but it's also going to be the same distance for triangle B. So we can use that to then move over to the triangle we actually care about. Okay, all that being said, we're going to start working over here in the green triangle. We want to set up some little SOHCAHTOA to help us find the hypotenuse. So, what are we working with? How do we find the hypotenuse here? I know we need the H, and I know we need the hypotenuse. So we're working with either SO or CUH. Heard a couple people saying CUH or cosine. That is correct. We want to set up a little cosine. And again, this has 3 pieces, and we gotta have at least 2 of them. And we do. What is the angle going here? 40. What is the top number gonna be?
6.
And what is the bottom number gonna be? I don't know, right? That's our hypotenuse. Okay, now for this setup, do we need to use second cosine or regular cosine? This is regular cosine. We are only using second cosine if we are missing the angle. But for this one, we have the angle. How do we solve for H or solve for, again, this was the homework last night. Right, we talked about how the long version, multiply by H on both sides, and then divide by the cosine. We talked about the pattern that we learned is that basically the H and the cosine are gonna switch places. So we're gonna go here. Do we get that?
Yeah.
Alpha y equals inner 6 divided by cosine of 40. I got a distance that is less than 10. Is that what you guys got?
Yes.
Sweet. I got that H is equal to 7.83. We're good with that? Now that is not really the long-term answer we want, but it is gonna help us. Because now, forget that first triangle. I don't need that first triangle anymore. Now I can look at this second triangle. I just figured out this piece, which is now giving me 2 out of 3. So now I can find that third piece. I know that the H, 7.83. How am I gonna go further? I need a new SOHCAHTOA. Need a new trigonometric function here. Okay, I like that. I heard again. Cosine. The X is a mystery now. The adjacent is 5. And then we have 7.83. Right. This time we are gonna need second cosine because we're missing that angle. And so nice job. Second cosine, alpha y equals inner 5 divided by 7.83. And we're getting the answer of so that's a little two-stepper. We had to figure out the first triangle, so then they were touching, and we could relate to the second triangle. I'll say pretty much, if you got 2 shapes that are touching sides, you almost have to work in the wrong one first before you're allowed to work in the one you actually want to work in, right? We wanted to work in triangle A here, but we had to do a little bit of work with B first. That's the pattern of all these types of questions. We have 5 minutes to lunch. What does it say here? Solve the triangles below. Cool. We're not gonna do this. We can just get rid of this one too. So solve the triangles below. Perfect. Solve the triangles below. When it says solve the triangle, that means find find, but find everything. I need you to figure out all the sides. I need you to figure out all the angles. And as much as that sounds crazy, triangles are small little shapes. We got 3 sides, we got 3 angles. Not only that, it's already going to give us 2 of those 6 pieces. So we only need to find 4 things max. And lastly, with a little bit of thinking, a lot of times you can find out these other stuff too. For example, I know that for this one, we're missing this bottom angle, angle C, but I don't even need a calculator to figure out what angle C is. Can anybody do that in their head? 70. And where the heck did 70 come from? That's kind of a random number. Because a triangle has 180 degrees total in it, right? Back to geometry. We know this is 90. We know this is 20. That makes 110. And so how many are left to fit for this triangle? It's going to be 70. Now, you could have done the longer way. You could have found some more sides. You could have done a second tangent to try to find the angle. Or a little bit of geometry, boom, it's 70. All right, cool. We need a couple more things. We need to figure out what the opposite is, and we need to figure out what the hypotenuse is. And here's where I want to pause you for just a second. Remember, whenever you set up a sine or a cosine or a tangent, you gotta have 2 out of the 3 things. And so where everybody's gonna get stuck here is they're gonna say, well, we want the sine of b, which is 20. But the problem is, once you set this up, the sine of b, which is 20, do we know what the O is? No. Do we know what the H is? No. And so it's like, maybe I'll use a Y, and it just falls apart. So that's not how we want to set it up. I know that we're missing 2 things, but you gotta tackle them one at a time. So, somebody give me a SOHCAHTOA and I'll see if it works for you. What do you think? Okay, so we can use tangent. Are we using 20 or 70?
70.
Okay, tangent is 70. We'll be able to figure out either way. That means we are standing here at the 70. The opposite number is, and the adjacent number is, opposite and adjacent would be right here. Now, when I had first labeled them, I labeled them from 20. That's why I used A and H. Not a big deal. From here, we're going to do our calculating. Remember, the A and the tangent are going to kind of switch places. I'm going to do alpha y equals enter. 14 divided by tangent 70, enter. Okay, nice. I'm getting that this side over here is looking, A is equal to 5.1. And I always want to double check. In the grand scheme of things, does that make sense? That is definitely smaller than 14, but it's not crazy small. I think that looks really good. Now, I got one more step to make. 5.1. I need to find that H, so I need to use cosine or sine. Anybody want to come up with one for that? Okay, cosine. Now here's a pro gamer move. Once I finish saying this, we're going to lunch. If we're going to use cosine, and we've already found this 5.1, if we're going to keep working here, if we got this wrong, it could potentially mess us up again. So it might be smart not to use 5.1 when we go to calculate the second thing. We have enough information to use other stuff. If we use the cosine of 20 is 14 over h, that's all legit, and we didn't have to use 5.1, which is just a little bit of a sketchy number, right? It's rounded, we found it might be wrong. All right, cool. Lunchtime, let's go. Nice job. Homework when we get back.